You're listening to NeoTalk, the official podcast of the Faculty of Modern Languages at the University of Warsaw. My name is Maria Usakowska. We're living in the age of the AI craze. Or is it perhaps an AI scare? After Chat GPT was launched in 2022, some have named the 21st century the age of AI. But its history actually reaches the 1950s. In this episode, Professor Georg Rehm from the German Research Center for Artificial Intelligence joins us to debunk some of the myths and misconceptions about AI. Professor Georg Rehm works as a principal researcher in the Speech and Language Technology Lab at the DFKI in Berlin. Currently, Georg Rehm is the coordinator of the EU-funded project Language Data Space, co-coordinator of the EU-funded project European Language Equality, and works as a researcher in many other projects. He served twice as the secretary of the EACL, European chapter of the Association for Computational Linguistics. After completing his PhD in computational linguistics, he led projects on the sustainability of language resources and technologies. Today, he will explain how we train a large language model such as Chat GPT and what problems scientists come across when feeding them data from websites, as well as what is language equality and why we as Europeans should care about it. This conversation was recorded back in December 2024 during the Humanities Society Identity Congress at the Faculty of Modern Languages. I hope you enjoy. Professor Georg Rehm, welcome to NeoTalk. So good to have you here.
Thanks for the invitation.
So today we're going to talk about AI mostly, and let's jump straight to it. I want to start with Chat GPT, of course, because that's like a very big topic right now. It was launched for the public 2 years ago in November 2022, and it was a craze, and suddenly everybody was using it, and I think it was perceived as something revolutionary, something that up until that point probably most people knew from like sci-fi movies. But the history of AI actually starts almost 70 years ago. So could you briefly talk about that?
So still many people today think AI is just a recent field, new development this century, which is not true, as you say. AI as a field was developed or started at a very famous workshop at Dartmouth College in 1956, where all the people who formed the field, who did the important groundwork like John McCarthy and Marvin Minsky, came together for the very first time to talk about a topic that they called artificial intelligence. And then everything started from there. And many different steps happened in between that workshop in 1956 and then November 2022 when Chat GPT was released as a kind of AI tool, which it is. I don't want to go into too much detail here, but essentially we can distinguish 3 different phases, maybe 4 phases. So first of all, it became pretty clear quite soon after that 1956 workshop that language plays a very important role when you try to develop machines that have some kind of intelligent behavior, whatever that means. So you need to take language into account, how humans communicate, how humans store knowledge in their heads, how we reason about the knowledge that is contained in our heads, and so on and so forth. And out of these thoughts and the very first application that was envisioned by the early AI people, there was machine translation, so translating texts of a certain language into another language automatically. And for that, you clearly need to have some knowledge about language, obviously. And out of these discussions and debates, the field of computational linguistics emerged eventually in the, let's say, late 60s, early 70s, which is still a very prominent field between computer science, AI, linguistics, cognitive science, psycholinguistics. And in the middle there somewhere is computational linguistics, which also has to do with natural language processing, which is more in the AI area. But essentially, maybe for the sake of the podcast, computational linguistics, natural language processing are part of AI. So that was one important development. Then the very first methods were, based on what we know now, quite naive even. People sat down and started writing certain processing rules manually. Grammar rules or semantic rules were written just by intellectual introspection, and then you created whole grammars just based on your knowledge about a certain language. This was then superseded, let's say in the 90s, by statistical methods, where we started looking into annotated corpora, large document collections that were annotated with linguistic phenomena, sentence boundaries, part of speech tags were added, and so on and so forth. And then you could do actual empirical analyses of linguistically annotated data, which was great. And you could also use that data to implement first statistical systems for language processing, which was a big step forward. So from symbolic methods, purely symbolic methods, to statistical, yet still symbolic methods. And then again, let's say 2 decades later, we arrived at neural technologies, which have been around for decades, but now it's only possible with current hardware setups and really highly capable machines to train neural technologies, neural networks that are able to capture much, much more of the actual language use by taking large data sets, taking the statistical probability distributions that you find in these data sets. And with this information now that we have, you can do many, many interesting things. And one of the things is develop language models. And this is where Chat GPT comes in. Chat GPT is a very large language model, which has been fine-tuned a couple of times with additional information. Human preferences also, where humans then annotate the data internally and say, this is good output, this is bad output. And then you end up at a system that is able to essentially be a partner in a conversation. You can talk to Chat GPT, you can instruct it to do certain things, you can ask questions, it can interpret photographs or sketches, it can even produce software code based on a sketch of an interface of an application that someone draws on a napkin. These are very interesting, almost magical capabilities, and we are still learning to understand all the different details that we need to take into account to build such a system.
Is it true that scientists who work with AI don't necessarily understand exactly how these linguistic algorithms work?
Yeah, it's true to a certain extent. The mathematical foundations are pretty clear, but the way a system that is based on a language model then arrives at certain or computing certain output, there are still things that still need to be discovered. We often use in papers specific studies that try to get closer to the question why the output that was produced in a certain experiment, why that happened. Why it was computed the way it was computed. And there you need to add additional effort and really look into the language model. You can take out certain things and see how the model behaves without this bit of the system or without that bit of the system, and then try to really isolate what the decisive factor is for a certain kind of computation of the model. I know in public press or in the popular press, it's often said that these are complete black boxes. That's not true. We know pretty much how they work, but certain details still need to be figured out.
A little bit scary anyway, I think.
At the end of the day, it's just math. It's statistical probabilities of words occurring next to each other or in a sequence. And then the language model predicts the next word. This is the basic operation. And then you can add many different things. For example, you can add a context window that is as large as possible so that you can put in as much additional context into your request or into your prompt, as we call it, as possible. A couple of years ago, that was just a tiny bit, maybe one sentence. And now we can have a context window that is then fit for processing of maybe whole documents that you can put in as input for the language model. Maybe you can feed it a PDF document and ask the model to produce a summary of the text contained in the PDF document.
Chat GPT is a large language model and it is trained on a vast amount of data. So how does this training work? Of course, in simple terms. And also I'm interested, where does the data come from?
Physically, the training works in very, very big, vast, fast, and also expensive supercomputers. So we have a couple of those in Europe. Other continents have other pieces of infrastructure, but you need very capable systems with tens of thousands or maybe even hundreds of thousands of GPUs to do the computation. And these systems also need very large storage subsystems. So laptops, we can see 2 of them here on the table, typically have 1 or 2, maybe 4 terabyte SSDs. But in these supercomputers, we're talking about dozens of petabytes, it's a bit more. Where does the data come from? Typically, the data that is accessible in the easiest way is web data. So we use web crawls. What is a web crawl? The web is a hypertext system. Hyperlinks point from page to page. The idea is you start with a certain page, and then you just go from hyperlink to hyperlink to hyperlink on each page, and you collect the page. You follow the hyperlink, all of them in a page. You store the page, and so on and so forth. The issue is the web is quite big with billions and billions of pages, so you cannot really collect them all, and they are also dynamic content, and you can switch languages, and can you do this automatically with a web crawler and so on. So there are dedicated projects for the collection of web crawls. They often do this on a monthly basis. They produce new data. Then you can take the data, you can clean the data, you can make it fit for processing, which all takes a lot of time, as often in AI and data science. Cleaning up the data, making the data work for the purpose that you wanted to use it with takes the most amount of time. And then you can apply certain methods for training language models. There are some packages that are available in an open source kind of way that already produce capable language models. Of course, there are many, many intricate details that you need to take into account, and you can pull certain levers to optimize the system. And at the end of the day, it's a very complicated process. The result, so that means a capable language model that performs well when evaluated with evaluation data sets and standard benchmarks. Then you can easily tell by feeding certain almost standardized data into the model. You observe the output of the model, and then you can say, that's a good model, or that's a bad model, or that's a so-so model. And there are hundreds of these benchmarks, and you can just apply them to see if the model performs strongly on question answering, or on medical named entity recognition, or this task or that task. So how it works is the training algorithm, which is based on a certain concept called transformer. It's called the transformer architecture, trains a language model based on the words and tokens contained in the training data, which are continuously fed into the algorithm, and the algorithm then produces a model based on the tokens, the tokens or the words. To simplify this slightly, you take the tokens, the content of the data, and then you apply this algorithm, and the algorithm computes probability distributions from token to token as seen in the text data. And the more compute, the more parameters you apply, the wider the context is in a certain way. And if you then go a few additional steps and you train the model also to follow instructions, to follow dialogue, to have certain human preferences, that this is maybe bad output and this is good output, not useful output, then you eventually arrive at a system that you can have a chat with.
Can you provide an example? What I mean is, I understand that, for example, you ask the model a question and the model answers, and then you kind of evaluate their answers, right?
This is a step called reinforcement learning with human feedback. So this is before the actual end user application. So the model produces output for certain questions. These questions could also be synthetic questions or synthetic tasks, that have been produced automatically. And then humans, many humans, human users that are usually paid for that purpose, they then classify the output of the system into good output and bad output. And if you do that many times, you have enough data points to train another model that will help you evaluate the output of the model internally. So you don't have one language model, you have multiple models, but one reward model that adds a certain reward to your output internally. And then the best output is then presented to the user.
Right. I want to ask you about the data that the models are fed, because you mentioned that, for example, websites are used. So what are some of the issues that come with feeding AI with data from websites? I'm thinking, there's a lot of noise out there, propaganda, fiction, and so on.
That is usually drowned out by proper content. As mentioned, the cleaning of the data, making it work for your training process of the model, that takes a lot of time. Typically what we do when we train a model, big one or a small experimental model, is we try to get rid of the noise. That can be just cookie banners, for example, or just navigational bars, navigational menus, or imprints, which you don't want necessarily in your language model, or adult content. So this is typically filtered out. And propaganda content, it exists online. We know the issues, but for training a model, it's not that relevant from my point of view, because the genuine content, the true content prevails because there's much more of that. Yeah. And also propaganda is typically also taken care of in the reward model annotation phase when people say, okay, this is bad content. But here we don't really know how the big companies that develop these models commercially as commercial products, we don't really know how they do this, based on which principles they do this. They do not apply open science principles, where when we do projects or experiments, we document everything. Everybody can check the project website or the GitHub repository and see how we annotated the data, how we evaluate the data. This is all very transparent and clear, but this is simply not documented. And these big companies, they also don't say that they would document this in any way, shape, or form. So we have to guess in a certain way. We have to rely on their word almost, that nothing shady is going on behind the scenes. But at the end of the day, we can also observe maybe shady behavior when training and developing the model in the output of the model. Yeah, it depends. This has been so far not observed anywhere, but yeah, maybe this is something that will come in the near future. We have to see. Remains to be seen. Especially in global politics, we have seen many surprises recently. Regarding the data, maybe one or two more observations are that we have lots more data for the English language than for any other language. I think the next one is then Chinese globally. But looking at Europe, there's a big problem with the availability of data for the European languages. In one of our projects, we found that English is by far the most supported language, followed by Spanish, French, and German. And then there's another big gap. Yeah, there's already a gap between English and the three languages I just mentioned. And then there's another big gap. And then we continue, I think, with Finnish and Italian, Portuguese, and so on. But all of these languages only have a fraction of the data availability as the English language. And this is a problem, of course, because if we want to train models for these languages and the speakers of these languages primarily as applications, we can't do that. Yeah. So there's no way to produce a language model, let's say, for Welsh or for Maltese, because there's simply not enough data available. And right now, considering the European situation, I'm now coordinating a project in which we are trying to change the situation. It's called the Common European Language Data Space, and we are trying to develop an infrastructure with a very low entry barrier so that organizations that have data, podcast data, by the way, also counts, that these organizations can then make available the data that they have through the language data space for those that may need the data. So it works in a fully decentralized way. You can install a piece of software. It's called a language data space connector. You can then say, okay, here's a bit of data in this zip file or here on this hard drive. And then you can semantically annotate the data. You can provide a brief description and say, okay, this is, let's say, Polish podcast data, and average length is, let's say, an hour. Topic, scientific debates or whatever, something like this. And then you can send this out into the language data space marketplace as an offer for others to see it, and then say, maybe others need this data. And then you can exchange or you can have a negotiation phase and then either directly transfer the data or buy the data if it's commercial data. This is also foreseen. And this is something that we desperately need to change in Europe, is data availability, because the well is running dry, as one article put it. We need data for all European languages, and ideally as much as possible, as high quality as possible, and as up to date as possible.
So I could also put my podcast out there okay, maybe I'll do that. Can you explain why is it so important that the European languages are technologically supported? Like from the perspective of a, let's say, regular user, European user.
The European Union is based on the European Union Treaty. And the treaty says, and that was a very smart move, that all languages spoken as official languages in the member states of the European Union are equal. So politically, all languages are equal in Brussels and in Luxembourg, where the European institutions are situated, and in Strasbourg, obviously. You can hear all sorts of languages, predominantly, yes, English and French and maybe German, Spanish also. But these are more like working languages in the Commission, in the Parliament, which you hear clearly more than Latvian or Maltese, for example. But politically, in the Union, all languages are equal. Technologically, turns out they are not. So, as mentioned a few minutes ago, English is by far the most supported language, and all the other languages are, as we call them, under-resourced. The issue is then that speakers of these languages that are under-resourced need to fall back to other languages if they want to participate in the information society, if they want to use current systems, like web search or the systems available in their car, for example, in their phones. Just as an anecdote, it took the people in Maltese a couple of years to have full support of the Maltese language in Android and iOS phones because they couldn't type all the characters that exist in the Maltese alphabet because they weren't available in the phones. And they had to actually lobby with the producers and manufacturers of these phones. And now they can use their languages fully in the devices that they have access to. Topics like this. So it's about digital sovereignty as well. It's about not leaving anyone behind, not saying that one language is more important than other languages, and not participating or not contributing to what we called many years ago digital extinction, digital language extinction, which would happen eventually, because if there's less support for Maltese than for other languages, people will use Maltese online less. And then that registers as lower signals with the people who produce language technologies, and then eventually nothing will happen for Maltese, and then eventually the problem will be that you cannot even use Maltese anywhere anymore. So that's what we call digital language extinction. And this is something that we want to change with different projects like European Language Equality or our Otziglot initiative, where we specifically focus on developing language models for all European languages, also often together with colleagues in those regions and countries where these languages are spoken.
Can a regular citizen somehow provide this kind of data? Apart from, because you gave an example of, let's say, me sending the podcast or something, but what about a person who doesn't really create any content in that way?
That type of data, so let's say individual data, is probably only the proverbial drop in the ocean when examining the grander scheme of things. We are primarily targeting those organizations that really have lots and lots and lots of data that can really make a difference when training a language model. Personal data, like an email archive or so, or maybe personal papers, documents, probably will not make a difference. It's also not foreseen in the language data space. However, it is a good point. There are certain regions and countries like Icelandic, spoken in Iceland, obviously. Many younger people in Iceland only learn English, which is of concern. And there's been a couple of years ago a dedicated program funded by the Icelandic government to produce digital resources for the Icelandic language. And they did this in a concerted, systematic way where you had access to an iPhone or Android app on your phone, and then you could actually just provide a sample of your own speech by speaking into the phone. That data was collected in a systematic way in a data warehouse to have speech samples. And now there's great speech data, so spoken language data for Icelandic that can be used for all sorts of downstream applications like speech recognition or speech synthesis, where we automatically generate spoken language. Something like this is very helpful, but needs to be done in a systematic way.
Speaking of data, some big companies like Google or Apple or OpenAI are buying data from providers such as Reddit and CNN for immense amount of money. Do you think there is some potential of unethical procedures or consequences in this process? Because you also mentioned that their technology is not openly accessible.
Which is okay. They are commercial companies, and they disclose in scientific papers or in GitHub repositories or other open source repositories what they want to disclose. This is all fine. These data arrangements and data deals with data providers from Europe are essentially also okay. There's one thing that I find concerning, and that is the amount of money involved, and which is something that we as the language data space cannot really compete with, and we don't have any money in our project budgets to buy data from these organizations. That's not the point. We want them to participate in an open and accessible language data space as a marketplace so that they can continually provide data for those organizations that want to either get access to the data or who want to buy the data, which is also possible. And this is a market in Europe that currently doesn't exist, except for the examples you mentioned. Yeah, so it's 2 or 3 bigger players with very deep pockets who are able to pay sums that exceed even very big European project budgets for one data set. Okay, the data set is very big, yeah, maybe very interesting for model training, for example, or for providing news to a model, among others. But this situation is difficult to compete with as a project that is trying to implement and deploy decentralized infrastructure in Europe, where the goal is to establish the infrastructure and where the goal is not to develop a commercial product that is then a language model. Yeah, so there are many steps in between. We are only concentrating on this marketplace, and this is a challenge that we are currently working with. In our user group in the language data space, we already have a 3-figure number of organizations that want to participate, which is good, but it's not enough. Yeah, we need ideally 4 figures, 5 figures of organizations that participate, covering all the languages, covering all the domains, from the legal domain to the medical domain to media, broadcasters, and so on. And then we're talking, hopefully soon.
Why can't we use the models that are developed by the US and China? Is it only because of the language aspect, or are there other aspects? Because I'm imagining maybe it would be like easier if you took that and adapted it, for example, instead of creating your own from the start.
Multiple different aspects come into play here. So first of all, they are commercial products, which is okay. We use them on a daily basis, but they are also closed products. We don't know how they operate. We don't know how they arrive at certain conclusions or results or outputs, which is probably not that concerning when looking at the majority of use cases. But earlier today at our conference here in Warsaw, we also talked about the crisis of truth. And sooner or later, we will have a situation, especially with the recent elections in the US and the predominance of a certain figure who happens to own a social network and who happens to own a company that produces rockets and another company that produces cars, soon self-driving cars. He also happens to own an AI company that produces a language model. And that certain person currently is pushing narratives on his social network. It's difficult to say this, on his personal social network, for example, that raise questions regarding why does the EU exist and why is Germany paying so much money? What is it getting out of this? So very much anti-EU narratives are currently being pushed.
And anti many other, minorities groups.
Absolutely.
And so on.
Absolutely. So this is happening right now by a person who's perceived as a thought leader in another continent, but also in Europe by many people. And what is concerning here is not this specific case, but I can see a possible future where the language model that this company provides will also be shifted into producing output that serves these narratives. And then things are getting really complicated, first and foremost, but also much more concerning when you observe that nowadays many young people use language models and Chat GPT and other products as search engines. Yeah, so how did this and this happen? How big is the Eiffel Tower? Where is that building located? And so on. And then you cannot control anymore, and maybe control is not the right word, but you have no way of
fact-checking.
Yeah, it's not only fact-checking. Yeah, we talked about this earlier. Critical thinking is an important piece of the puzzle beyond AI, beyond language models. Yeah, so many people have stopped with doing that, applying that principle. That needs to happen more, needs to be reinforced more in education. And if we now go back to Europe and what we do, we want to reclaim leadership again in AI, which we had for many years. But in this specific field of developing language models and applying them, we are a bit behind now. Yeah? And the European Commission, the Parliament, the Union, the countries, everybody is chipping in and things have been fragmented. But now there's lots more coordination going with bigger projects and also pan-European projects where we want to pool resources in one big infrastructure. This is all great, but we're running out of time, not only in the podcast, but also in this initiative, because we have to be fast so that we can finally develop capable language models on the same level as the competing technologies that adhere to our cultures, our languages, our values, and not to some alternative facts.
Mm-hmm. Last question, because I know that you're literally going to the airport right after this. If there is one misunderstanding that you think that generally people have about AI, what would it be and how would you correct it?
Oh, there are so many. One misunderstanding that many people still promote is that AI will take over, it will destroy humanity. No, it's not true. Even if some people say this who appear to be well educated, at the end of the day, we're talking about software systems. And if a software system doesn't do what you want it to do, you can pull the plug and then it stops working because it's running out of electricity. And it will never, ever destroy humanity unless someone thinks about a clever new trick, and that is attaching a nuclear arsenal of rockets to a language model, and then by accident, maybe this will happen. But I don't think anyone is stupid enough to do such a trick.
Let's hope. Professor Rehm, thank you so much for being here, for dedicating this last hour of your stay in Warsaw to this podcast. And please come back to Warsaw.
Thanks for the invitation. Happy to be here.
Thank you.
This was an episode of NeoTalk, the official podcast of the Department of Modern Languages at the University of Warsaw, recorded in the Radio Campus studio. Franek Wójcicki edited this episode, and the cover art is by Weronika Rosik. Please check out our show notes if you're interested in the books and other sources mentioned in this episode. You can follow us on Instagram and Facebook. If you have comments, questions, or suggestions for topics we could cover, email us. My name is Maria Usakowska. Thanks for listening.